Continuing with the example from our previous video, we are going to cross multiply here, and when we do, we get 2.5 times the cosine of theta cubed, cos cubed theta, and that will equal sine cubed theta. All right, from here, what I'm actually going to do is actually divide both sides by cos cubed theta. The reason I'm going to do that is because it'll leave us with our 2.5 on the left side, and on the right side of the equal sign, we're going to end up with sine theta over cos theta all cubed. So sine theta over cos theta all cubed. Now the reason I'm doing that is because sine theta over cos theta we know is just tan theta. And that will help us be able to figure some things out here. So we've got the tan cubed theta now being equal to 2.5. All right, at this point, I'm going to cube root both sides. And when we cube root, we just get the one answer, the positive answer, and that's going to equal the tan of theta. And then to get theta by itself, of course, we do the inverse function of tan on that cube root of 2.5. And that, I'm just going to pop into my calculator. It's not going to be a nice special angle here or anything. I'm going to pop that into my calculator. I'm going to work with radians. And when I do, I get about 0.94 radians. Okay, so that's the angle the ladder is going to be put at. I would also check and make sure that does give us a minimum. So my theta, the smallest angle the ladder can make with the ground, would be 0. And really the biggest angle I could have would be pi over 2. So I'm going to, because that would be straight up in the air, and we know that that's not even possible. So I'm just going to set my chart to reflect that, and then I'm going to check the sign of the derivative, L prime, and then that will tell me whether my function, my L, is increasing or decreasing. And when I do that, I used 0.5 here, and we might use like 1 here. We can put that into our L prime function. I did get a negative here and a positive here, which meant I was decreasing, and then increasing, which did give us a min. Therefore, it's a min at theta equaling 0.94 approximately. And now I just need to figure out what that actual length of the ladder is. So I go back to my length equation. My length equation was 2.5 divided by the sine of theta. And theta, I'm just going to use that 0.94, and then plus 1 over the cos of theta. And you pop that into your calculator, and I get approximately 4.79 out of that. So the ladder, the shortest ladder, would be about 4.8 meters long if I go to 1 decimal place. So hopefully that makes sense. It does take a little practice to work with these questions, but give it a shot and let me know if you need any help with anything.